Greetings. I'd like to take a little bit of time to discuss what are Cuisenaire rods. They may or may not be familiar for you. However, they can be used in a variety of different ways and many different grade levels. So what are Cuisenaire rods? You can see that they're outlined on the right-hand side of your screen. But before we get to them, let's talk a little bit about the history and where they came from. A Belgian elementary school teacher, Georges Cuisenaire, in 1952 developed them for his elementary classroom so he could help students better understand arithmetic. These are similar to Frederick Froebel's wooden 1-inch building cubes that varied from 1 to 12 inches, which were developed in 1826. However, George used the 1 centimeter cube, so much smaller cube, and he assigned a different color for each length. As you go through, and if you were to Google or look up Cuisenaire rods, there are many different varieties and usage for the colors. These are the main colors listed on the right. There is no rhyme or reason for why the colors are chosen the way they are. As you can see, they are rectangular blocks. We see that there are 10 different colors, and each color represents a different length. The white rod at the top represents a 1 centimeter by 1 centimeter by 1 centimeter cube. The red rod represents a 1 centimeter by 2 centimeter by 1 centimeter cube. The green rod represents a 1 centimeter by 3 centimeter by 1 centimeter cube, and so forth. The way that they are stacked, we call this a staircase. We can use in kindergarten through 2nd grade a variety of different ways by comparing, counting, spatial visual, equivalence, and addition. It is important to introduce Cuisenaire rods very early in kindergarten or even pre-kindergarten and allow students to play with them first, which provides natural engagement of these hands-on manipulatives. Take the 3 same rods that I have below. So the purple, the light green, and a purple on its side, like I have mine. Pause the video and find some different way that you can arrange these same 3. Now, the application in which I use to find these, we can find at our learning management system course in Blackboard. You'll be able to see the link that I have for the virtual pieces. Or you can click and print off your own and color them if you prefer. But take a moment to pause the video and see if you can rearrange these same 3 rods in a different way. Once complete, take a moment and compare yours to mine. Write down a few statements on how they are alike and how they are different. Did you come up with some items like this? They have the same colors. They use the same number of rods. Did you use any other words such as bigger, smaller, taller, longer, or wider? Or perhaps you used words like on the right, at the top, underneath, and above. All of these are wonderful explanation words, and descriptive words that we're trying to get kindergartens through 2nd graders used to using as descriptions. Perhaps, did you make a recognizable shape such as a triangle? Or did you create a free-form shape out of your imagination? Does this figure have 4 sides? This is a trick question because some students may think that this figure has 5 sides since we use 5 rods to create it, when in fact that is a false statement. There are still 5 sides. 4 sides. However, we are using 5 rods to create it, so there are only 4 sides. We also see that this figure has square corners. Now let's use those same 5 rods and create a new shape. So I'm going to, using the app that's located within our course, we only can use our rods horizontally or vertically. So let's envision that I put this top rod as such and swing this bottom right corner to attach to this top left corner so that it sits at a diagonal. We notice that although the new shape still uses the same 5 color rods, the new shape has only has a square corner here and a here, but we also have a slanted piece. I want you to choose at least 5, but no more than 10 rods. You can use rods over again, so you can use more than one of the same color, but I want you to choose 5, but no more than 10 rods. Then I want you to build a boat with those 5 to 10 rods. And make sure that the boat lies flat so we're not creating a three-dimensional shape. Take a moment to do that. Pause the video before moving on. Pause the video and take a moment to see if you can make something. Coming back, estimate how many white rods you would need to cover the boat. Make an estimation. Write it down. How could you figure out how many white rods you would need to cover your entire boat? Take a moment to think about that. I'm sure there are very many different ways in which you can do that based on what your boat looks like. Here's an extra special challenge for you. Use exactly 1 rod of each of the 10 colors and cover the design. Use exactly 1 rod of each of the 10 colors and cover the design. See if you can do that. If you get a solution, I'd like you to email that to me. I'd like to see everybody's results because there are many different ways in which you can do this, but you only can use 1 rod of each of the 10 colors. Find a rod that is longer than the dark green, but shorter than the orange. What one could it possibly be? Pause the video and see if you can figure that one out. It's longer than the dark green, but shorter than the orange. What could it be? Do you have an answer? How do you know that's the correct answer? It could be the black, the brown, or the blue rod. We could show this since it would take a black plus a light green to equal the same length as an orange, or it would take a brown and a red to be the same length as an orange. See if you can find a train. A train, again, is when we put 2 different colors, 2 or more different colors end to end. Find a train that is as long as a blue rod. It contains exactly 2 rods of the same color, and the train has 4 cars. So when we line them up end to end, all of the together is called a train, and each rod that we put end to end is called a car of the train. See if you can make this happen. So it has to be as long as the blue, and exactly 2 of the rods are the same color, and it only has 4 cars in the train. Pause the video, see if you can make that happen. This is the one I got. So I started with my blue because I knew that it had to be as long as the blue. And I picked 2 rods that were the same color that would fit above, but yet I was able to fill in a purple and a white so that it was the same length as a blue. Is there more than one solution? Absolutely, there is more than one solution. So if you had something different than myself, don't worry, it is correct. There are many more. I can show this in an addition statement because 1 plus 4 plus 2 plus 2 is equal to 9. So I just showed a way that I could decompose the number 9. Let's try another one. Let's find a train that has 3 cars. The largest car is brown. Each car is 1 red rod longer than the last car. I know that the largest car is brown, so I first started with a brown rod. Then, since I knew that each car is 1 red longer than the last car. So if the largest car is brown, I cannot have a larger car than brown on here. So I would need to put a red car here to start with. And I would see that if I had a red car here, in order to make up this exact same length, I would need the dark green rod. And 8 plus 6 plus 2 is 16. So we were able to decompose 16. Choose 2 different rods of your choice. Which one is longer and by how much? How would you prove this? Take some moment, jot down some thoughts. There's no right or wrong way to prove something, but just showing and using your rods to do so. Currently, choose a red, yellow, or orange rod. Build a train with a collection of no more than 10 rods of the same color. So choose red, yellow, or orange and line them up end to end with no more than 10 of them of the same color. Record the numbers you would say to skip count. So I'm going to choose red, and I'm going to line up, let's say 6 of them. Then if I skip count, knowing that reds are each worth 2, I would get 2, 4, 6, 8, 10, 12. How would a mathematician write this? Well, there are a couple of ways. We could say that if we added 2 plus 2 plus 2 plus 2 plus 2, etc., that is equal to 12. Or 2 times 6 is equal to 12. And on the top there, I lined up the orange rod and a red rod so that we see that it is certainly equal to 12. Can you find 2 rods that when put end to end form a train that is as long as the yellow rod? Can you find 2 rods that when put end to end form a train that is long as the yellow rod? They don't have to be the same color. One option would be the light green and the red rod. Another option you may have found would be a purple and a white rod. Note, this teaches the commutative property of addition because it doesn't matter the order in which we place them, they're still going to add to the same thing. This leads us from concrete to representational. So in kindergarten through 2nd grade, as we are moving through here, it sets us up for our later grades. Right now, we're using manipulative hands-on concrete materials. Soon, we'll be using the representational of a part-part whole chart, where on the top we have 2 plus 3 would give us our whole of 5, or 3 plus 2 gives us the whole of 5, or even using number lines. Then finally, this leads us to the numbers and mathematical symbols of writing out the addition statement that 2 plus 3 is 5 and 3 plus 2 is 5. I'd like you to take a moment to pause the video and fill in the chart of all possible 2-car trains that can match the given rod. So I have all of them listed on the top, and on the bottom are the possible 2-car trains that make up each one of those full rods. All possibilities I'm looking for. Pause the video, take some time to do that, and then we'll check our answers.